So a geothermal heating and cooling system is 3 to 5 times more efficient than any other kind of heating and cooling system. It is more efficient because it moves heat from this gigantic, almost essentially constant temperature reservoir, which is the ground. So the temperature of the ground in this area of the country is about 50 degrees Fahrenheit year-round. So that's a key factor that makes geothermal heating and cooling more efficient. In the summer, energy is extracted from indoors to lower the temperature and is deposited in the ground. In the winter, energy is extracted from the ground and deposited indoors to raise the temperature. A geothermal system moves energy to and from the ground by using fluid-filled tubes inserted in the ground. A typical depth of these tubes is about 150 to 400 feet. An assembly of these tubes is called a loop field. The buried loop field is the only part of the system which is outside, so you see nothing, and so there's no a problem with vandalism or that sort of thing by having equipment outside. So loop fields typically last, they're guaranteed for 50 years, but in reality should last much, much longer. They use the same material, high-density polyethylene that the gas company used, except that theirs is usually yellow. The ones used in with a loop field is usually black. Okay, because it pumps heat to and from the ground, another name for a geothermal heating and cooling system is a ground source heat pump. And that's actually the preferred name because it's more descriptive and it avoids possible confusion with a geothermal heating that you get steam from thousands of feet under the ground. So the energy moved to and from the ground is free, but it takes energy to operate the pump. So for each unit of energy that the pump uses, it can move 3 to 5 units of energy. So you put one energy unit out, you get 3 to 5 units out. By comparison, a conventional heating system, you put 1 unit of energy in and you get probably something almost 1. So for the highest efficiency conventional system, you put 1 energy in out, you get almost 1 energy unit out. A ground source heat pump system, you put 1 energy unit in, you get 3 to 5 units out. So that's the reason why a ground source heat pump system is 3 to 5 times more efficient than any other kind of heating and cooling system. So compared to a conventional fossil fuel heating system, a ground source heat pump system can reduce one's energy use by 60 to 80%. So for every kilowatt hour of energy that is saved, you can avoid the release of 1 pound of carbon dioxide in the atmosphere. So that's data from ComEd. So for every kilowatt hour of energy that they provide, they release into the atmosphere 1 pound of carbon dioxide. So by using a ground source heat pump system, so for every year you would be avoiding the release of tons of carbon dioxide into the atmosphere. So over the life of the system, that would be millions of pounds of carbon dioxide avoided. Thank you.